Hi, I'm Jason Carroll.
I'm Jasmine.
Hi, Barry.
And we're team babyBottleBop. So what our project is we've been working on an attachment for a baby bottle that will be able to track the feeding habits of babies. And the way that it does this is that it registers when it's being placed flat on a table, and then it'll start recording data, the weight of the baby bottle, and then the parent picks up the bottle, uses it to feed the baby, and then when they place it flat on the table again, it'll start recording data, and then from that you can determine the difference. And that information will be used by researchers to find trends in feeding habits. So the reason that we chose this project is because we wanted to become more experienced with writing firmware and working with embedded systems, and we also wanted to practice PCB design and implementation. So our primary client is Dr. Allison Ventura from the kinesiology department. She's the one who came up with this project and the one who's going to be performing the research on the data. And we also have Dr. Ben Hawkins from the biomedical engineering department. And he is the one who's primarily in charge of the engineering side of the project and has been also involved in the electrical design. And lastly, we have Professor Javier de la Fuente, and he's the one who's actually designing the case that the electrical components are going to go into, and then the silicone sleeve that the bottle fits into. And our primary stakeholder is Cal Poly, since the university is, since the research is going to be conducted under the university name, so whatever results from that occur are going to reflect on the university. And the researchers also are a stakeholder who second stakeholder is researchers who are actually going to be performing the research. And then we have the parents of the babies who are going to be utilizing the device. And then lastly, we have the babies who are going to be the primary benefactors of the research performed.
We've separated our customer requirements into 3 categories. The first of these is data collection. So our milk bottle attachment must be able to measure and record any weight changes of the milk bottle it is attached to, and it must be able to record when these weight changes actually occurred. And it must also have a way to actually export the data so that researchers can use it and determine, the actual feeding habits of the babies. So for this first requirement, we're using a load cell, which can actually, measure the physical weight changes of the bottle that it's attached to. And then for the second requirement, we're using a real-time clock with its own separate button cell battery in order to actually, keep track of what, the date and time is, so that when we make these recordings, we can actually record the actual date and time. And then for the last of these, currently, in our current prototype, we're just using a removable SD card, which actually we log the data onto, and then you can just remove it and plug it into your PC to actually do data analysis with. Our second category is safety. Our milk bottle attachment must be able to prevent the overcharging and discharging of the battery that it uses. Shout out to the Galaxy Note 7. We don't want babies exploding. It must be able to provide users feedback on its current condition. This includes the battery life, whether or not it is currently powered on or on standby, or whether or not it is currently functional. And then we must also have the attachment be waterproof. Could you go back? Sorry. To address the first of these, we're using the charging circuit on a microcontroller currently. We're not entirely sure whether or not it is going to be, fully safe, so we still need to do testing on that. For the second of these, we're using an RGB LED to actually report, different colors mean different conditions. And then for the last of these, our enclosure uses an O-ring to actually prevent and keep out any moisture. And this is obviously important because we're, doing research on babies, and babies can spill milk places, and we don't want that milk to get into our hardware and cause explosions. And the third of our customer requirement categories is maintainability. Our customers want our device to be modular so that, if, something was to drop, again, babies are using this. If they were to drop, if the parents were to drop it, we want it to be easily to repair. This leads into our engineering requirements. So our load cell must have a precision of 0.5 gram. This is because babies might, just drink a little bit, and we need to be able to tell exactly like how much are they drinking. For example, like, oh, never mind. The second of these is the battery life. It needs to last at least 1 week because the researchers give our attachments out to the parents, who then attach it to the baby bottle, and then after 1 week they get the attachments back so that they can get the data and then do their data analysis. Our connections need to be modular. Again, going off what I said previously, it needs to be easy to repair. The fourth of these is its memory. It needs to be extractable. Currently, we're using an SD card, but in the future, we plan to use a Bluetooth module so that data can be more easily extracted than having to take apart the thing and then take the SD card out. The fifth of these is the real-time clock. It needs to have a precision of at least 1 second because babies don't drink over minutes or hours. They drink over seconds. You might feed and then set it down, and we need to have at least a 1 second precision. The sixth of these is the charging and discharging circuit. It needs to be able to maintain the rechargeable battery at safe levels. We're using a lithium polymer battery, which has, can be hazardous. They can explode. Again, think about the Note 7. And the seventh of these is the enclosure. It needs to be waterproof because babies can spill, and we don't want, anything to get into our electronics so that we have to repair it. If anything, we just need to make sure that things are safe for babies. And this follows into our design development. So currently our prototype, as I've talked about, is where it's at, but we need, in the future, we need to fix more. So basically our clients gave us a PCB to work on and fix and improve. And currently there's still a few incorrect pinouts, and we need to fix those so that it allows the device to power on and work properly. We discovered that there's voltage step downs on the PCB that don't necessarily need to be there because the people that previously worked on it were using a 5 volt battery, whereas now we're just using a 3.3 volt battery, and everything is on a 3.3 volt logic level. So we can actually remove all those voltage step downs, and that'll conserve space, power, and reduce cost. We are looking to replace the through-hole connectors for the load cell with surface mount connectors, again, just to conserve space because it needs to fit within a little enclosure and attach to the bottom of a milk bottle. And then we are looking to add Bluetooth communication in the future so that researchers can easily extract data rather than having to, again, take out the SD card and plug it into a PC.
So some framed insights and opportunities for our project. So our client asked us to create 10 prototype milk bottle attachments, and so the housing is already created, and so the reason why we went with, or our client went with baby bottle attachment is because if we introduce a completely new baby bottle to the baby, it could affect how the baby feeds and overall skew the data. Next, we have to test the connections on the given prototype. So we have the previous group tested all the components together by wiring them up, but Ben Hawkins just connected or created a PCB without testing it, so that's one of our jobs. So we realized that there are a few problems, and that will mean that we have to print a whole new board and test that one. Next, we have to test and calibrate the load cell. So as Jason said, we want the load cell to be able to track up to the 10th place because a baby can drink up to 0.5 grams of milk. And if the load cell did not meet that, then we would have to get a new one, and that would also change the design of our board. Next, we have to update the existing firmware that was written by previous groups because we saw that there are a lot of headers that were not used, which take up a lot of space, and we plan on cleaning up the code also. So for the data path, first, so the baby drinks out of a bottle that has the attachment on it, and the PCB determines the weight of the board whenever it's placed face up. And that data is stored into an SD card, and weekly researchers would take the SD card from the board and extract the data. Another way is that they use Bluetooth and extract it remotely, but so far that is a pretty low priority for our project. So next is, when the device is powered on, all the sensors are on, and whenever the bottle is placed upright, it takes a weight measurement. And then it would start an idle timer, and whenever the bottle is moved again, the idle timer would reset, and it would take another measurement when it's placed down again. But whenever the bottle is not used for a while, it would go into low power mode to save battery, and the only thing on would be the accelerometer. So whenever the bottle moves again, it would sense it. All right, any questions?
Yes.
So I'm gonna miss this, but how can you tell when the bottle is either set down or if it's being used?
So currently we have an accelerometer on the board, and basically that just triggers an interrupt. And so basically if it's set down for like however amount of time, it turns off, and then after it gets picked up, it turns it back on, reinitializes everything. It's here in the flow chart as well. So basically, okay, so yeah, so that's pretty much how that works. Yeah. Yes.
Is there a chance that you can get, like, if it's Boolean, for example, is there a chance that you can get offsets that you actually record when they put it down and then when they pick it up, you stop? Or do you have things in place to ensure that can't happen? Like, how can you tell the difference between them setting it down and then picking it up? That makes any sense.
Yeah, I do see what you're saying. It's essentially, well, we haven't like gotten fully there yet, but the idea would be like when it's set down, if the accelerometer hasn't changed for a while, it's pretty much like, okay, this is going to be an idle state, like we're not moving at all. And then once it gets picked up, once there's actually like some like movement change, but not only that, but it's not only a movement change, but it's also after it gets set back down, which is determined by like being stationary essentially, is there an actual weight change? Because it might have just been moved, you know what I mean? So that's pretty much how that works. Yeah.
Do you know what your client plans on doing with the data and the trends that you're able to recognize?
No idea.
I was just kind of curious of the bigger picture.
It's basically just, all they really told us is it's just to track feeding habits for some research study.
I believe this one to be true. You are integrating Bluetooth into the next revision.
Mm-hmm.
The current revision does not have.
Correct.
And so the Bluetooth connection would then pair with a computer to then extract the data.
Exactly.
So you wouldn't have to forecast it.
Exactly.
Okay, thanks.
Okay. Okay.
I'm going to stop the video.
Okay.
Why don't we pause first?